Hi guys, welcome again as we attempt this question. Guys, I read the question first. In binomial expansion of 2p plus x into bracket raised to n, where p is constant and n is a positive integer, the coefficient of x squared is equal to coefficient of x cubed. Show that n is equals to 6p plus 2. And so guys, I have already prepared for that. This is the equation. Guys, we are told the coefficient of x cubed is equal to coefficient of x squared. So the first thing guys we are going to establish is the formula that we use for that. That is for binomial. So we shall have a plus b raised to n. This is the general formula. This one gives us a raised to n plus, that is, here we have b raised to 0. For b is b raised to 0 plus n a raised to n minus 1 all over 1 factorial b raised to 1. Then we also have plus n minus 1 a raised to n minus 2 all over 2 factorial b raised to 2. And finally we have plus n minus 1 n minus 2 a raised to n minus 3 all over 3 factorial b raised to 3. So guys, that is our equation of binomial expansion. And so we now come and apply it to this equation. This equation is 2p plus x raised to n. And so therefore this one we are going to have as the first function is going to be 2p. This is raised to n. And then we have x. This x is raised to 0 plus n 2p raised to n minus 1 all over 1 factorial x raised to 1 plus, you can write plus here, n minus 1 2p raised to n minus 2 all over, this is now 2 factorial x squared. Again guys, now we come to the coefficient that is of x cubed. That is another plus n minus 1 n minus 2 2p raised to n minus 3 x cubed all over 3 factorial. So guys, when we are talking of a coefficient of x squared is actually this and that, and we are told they are supposed to be equal. And so therefore guys, I come and equalize them. that is leaving out the x squared. So we shall have n minus 1, 2p, that is into bracket, raised to n minus 2 all over 2 factorial, which is 2, is equal now to n minus 1, n minus 2, 2p to bracket raised to n minus 3 all over 3 factorial, which is 3 times 2 is 6. Guys, now those are supposed to be equal. And so we can now begin to cancel what can be cancelled. We can cancel n, this n, and that n. We can also cancel n minus 1 and that n minus 1. Guys, we can also cancel 2 by 2, 1 by 2, 3. And so guys, we are left with here, this side we are left with 2p raised to n minus 2 is equal now to n minus 2, 2p raised to n minus 3 all over 3. Guys, we continue. This we can divide it by the law of indices to be 2p raised to n, 2p raised to negative 2. And on this other side, we can still do the same for 2p. Here we have n minus 2. Guys, we can even bring this 3 on this other side so that we have a 3 here. Then we have here we are left with 2p. We write it the same way. We divide it or we separate it in two parts by the law of indices, whereby we shall have 2p raised to n, 2p raised to negative 3. So guys, we continue. Guys, we can now cancel 2p raised to n and 2p raised to n on this side. So guys, we are left with 3, 2p raised to negative 2 equals to n minus 2, 2p raised to negative 3. So guys, from there we can now bring our negative, that is 2p raised to negative 3 on this other side. So we shall have 3, 2p raised to negative 2 all over 2p raised to negative 3. This is now equal to n minus 2. So from there guys, we can, by the law of indices, now transfer 2p raised to negative 3 up, that is to become the numerator. And this one now becomes 3, 2p raised to negative 2 multiplied by 2p raised now to 3. This one now gives us n minus 2. Guys, using the law of indices, we are going to add these two. If we add them, we shall have minus 2 plus 3, that is 1. So we shall have 2p, that is raised to 1. And therefore we can leave it the way it is. This one is equals to n minus 2. So guys, we are going to have 6p equals to n minus 2. And so therefore n is going to be equal to, we can now bring this to this side, it's going to be 6p plus 2. So guys, this is how it's supposed to be done. and I brought the 2 this side so that we have 6p plus 2 equals to n. But in writing, I have written n on this side, which is still the same as we require. And so therefore, guys, as you can see, this is what we were looking for. Thank you guys for listening to me. Bye bye.